So this is a really important idea, this idea of expectation. And so what is expectation? Well, expectation is thinking about probability over the long term. So if, for example, I'm rolling a dice and I start rolling it on any given roll, it's very, very hard to pick out what's going to happen. There's a 1 in 6 chance of getting any of the sides. And that should, if you've got fair dice, that should be a random chance of getting a 2, random chance of getting a 1 or 4 or 6. The expectation, however, tells us about what happens in the long run. What happens as we would do more and more and more of these trials? What do we expect to happen? Now, assuming our dice is in fact random, for example, the probability of rolling a 2 is 1/6. So if I roll my dice and I pick a number of times, so let's say we roll it 300 times, about 1/6 of the time I would expect to get a 2. So I'd expect to get 1/6 times 300, which is 50 twos. So I'd expect to get a 2 50 times if I roll my dice 300 times. Now, the word expect is very important here. If I do roll my dice 300 times, the chances I actually get exactly 52s is quite low, but I would expect it to be around that number. So this would be the kind of ideal situation, but given everything's random and it's happening quite by chance, you're probably not going to get exactly 52s, but you would expect to see it somewhere in that region. It gives us a sense of, in an ideal situation, if everything works out exactly as the math predicts, how many would we get? And that gives us a kind of idea of the number we're looking at. So if you go out there and do an experiment, you'll get an experimental probability, which tells you actually how many 2s did you roll when you roll 300 times. The probability we're just calculating with the numbers gives us an expected probability. And that is the kind of, you'd hope that the experimental and the expected are very close to each other. Now, we can look at some other situations involving expectation. So here I have a coin, 50p piece. There's the head side, there's the tail side. Again, my probability of flipping tails is a half. If I flip the coin a lot of times, so let's say we flip this coin 90 times, well, I would expect to get a half times 90, which is 45 tails. So I'm just doing my probability of getting a tails times the number of times I'm repeating this. Now we can extend this idea. We can look at some situations which we've already talked about a little bit. If I've got 2 dice, now you can go back, but you can find out the probability of rolling a total of 7. Well, what was the probability of 7? Well, you remember we had our sample space, and we had 1, 2, 3, 4, 5, 6. You might need to go back and look at your notes just to find the numbers that you need for some of the questions that are coming up a little bit later. You remember all of these diagonal entries here were 7s. The probability of rolling 7 was 6 out of 36. And that's the same as a 6. So I'm going to simplify that. So if I roll, and I do a whole lot of rolls, I do 108 rolls, I expect to get 1/6 times 108. You can work out what that gives you. That gives you, well, 6s into 10 goes once, 6s into 48 goes 8 times. So I'd expect to get 18 7s. Okay, and we could look at something different. So we could get the probability of rolling. Now let's pick a different one off here. So along here we had 4, 4, and 4. So probability of rolling 4. So in this we're looking at probability that was 3 of them out of 36. So that's the same as 1/12. So again, if I roll 108 rolls, I expect to get 1/12 times 108. 12 times 108, well, you can how many 12s go into 108? That's 9, times it by 1. It's about 9 altogether. Okay, so you'd expect to get 9 4s. So this idea of expectation is really important. If I do something over and over and over again, how many, on average, would I expect to get that are a particular outcome? Now, there is a final little thing that we're going to do with this, and I'm going to show you the style of question that we're going to do in a minute as well. So you will get some questions in a minute that require you to do these kind of calculations here, where you might have to find the probability. You will also be going to get some questions which involve probabilities given as decimals. So the kind of question we're talking about is, in a bag, probability of getting a red is 0.15. If I take out, and I'm going to put a little caveat in here, and replace, so that the probability doesn't change. We're always putting it back in. After we've taken it out, we're putting it back in, and then taking another one, gives a bag of shake, take another one. If I take out and replace 30 counters, how many times do I expect to get a red? So we're going to do exactly that same process, but this time our probability is given as a decimal. So my expected number is equal to 0.15 times 30, which is 4.5. Now, this highlights another really important thing. Your expected number does not need to be a whole number of things. So what this is really telling us, I expect to get maybe 4 or 5, somewhere between those two reds in my choices. So your expected number does not need to be a whole number of counters. So hopefully that gives you a good idea. The key thing that you need to take away from what we've done here is that expected is equal to the probability that's spelt wrong. Let's try writing that again. It is probability times by the number of trials, the number of times we're doing this. Up here we're taking 30 counters. So how many times, we call those trials, how many times are we doing this? Our expected number of outcomes is the probability times the number of trials. Okay, hopefully that gives you enough information to kind of get you started. I will give you a little set of questions now. There is also going to be an extension video showing you, this is kind of like toy probability, showing you how it works in theory. What I would like to show you in the other video is some examples of where probability and expectation particularly go a little bit further and start to apply to the real world. So I'd suggest you watch the other video. You don't need to take away any of the kind of knowledge in the other video, but it's for interest and to show you how this turns up in real life and is used in real life.